So this is second question. At a particular instant, a hot air balloon is at some height in the air and descending at a constant speed of 2 meters per second. At this exact instant, a girl throws a ball horizontally relative to herself with an initial speed of 11 meters per second. When she lands, where will she find the ball? Okay, let me get this smaller so I have room to draw. So as I was saying earlier, you should get into practice of always visualizing the problem situation so that you can see what you might be missing and you have a frame to think of the question concretely. So I have this hot air balloon which is descending at a constant speed. Let me call this VB for balloon. And at the moment that the question is referring to, this balloon is from the ground at some height. Let me call that H. And the question says the girl throws the ball horizontally with speed of, I'm gonna label it V naught. And it asks when she lands, where will she find the ball? And this is the reason I wanted to do this question is because this question illustrates kind of thinking you should start getting used to, and I want you to be able to highlight a mistake that's easy to make. So when you first diagram this question, there might be this temptation because it says she's throwing the ball horizontally to think of the ball as, well, being launched horizontally and then landing like this. Kind of very similar to the earlier question. And I hope when you are forming a mental image of this situation in your head, that maybe after getting the question wrong, that you will realize that that particular description isn't quite right. It's not self-consistent. I want you to imagine a hypothetical where the initial velocity is, let's say, 0 meters per second. So rather than launching the ball, the girl is just dropping the ball from rest. Then will the initial velocity of the ball, will that be 0 relative to the ground? Because the picture I'm drawing here is really from the perspective of someone on the ground. So that's the inertial reference frame, something you'll get to this week, that I'm using. So all the quantities you illustrate here should be relative to ground. And if you imagine someone who's on a descending hot air balloon and just lets go of the ball, then because this entire thing is moving at speed VB downward, the ball won't be at 0 speed relative to ground. If the ball was just released, then the ball should not be at, oops. So instead of initial velocity being 0, the initial velocity of the ball, if it's simply released from rest relative to the girl, it would have the same velocity as the balloon. Sometimes we call this inherited velocity. And if you haven't seen this before, it's an easy thing to miss. And I want you to highlight this so that you can learn to think of this. So that when I imagine the trajectory of this ball now being launched with the specified velocity of V naught, it's not starting out moving horizontally. It's actually starting out with some vertical component of velocity that's downward. So it'll be following a trajectory that looks like this, with some initial velocity that's not entirely horizontal. So, okay, so that's the setup. And the question is asking for when the girl lands, and this will be the delta x that she'll be looking for. So, so the previous question provided quite a bit of guidance in terms of what you should do to solve the question. This question doesn't, but the approach is exactly the same as if the guidance was provided. So in an earlier question, part A asked for the time the ball was in the air. And here, even though the question doesn't ask you that, you can kind of imagine that the same process will be useful. Or I guess this is maybe a little bit backward. So let me try to provide a more motivated reasoning. This would be one motivated reasoning. So you look, as you think through this situation, you look at what information is provided and what information you are looking for. So you are looking for this delta x, unknown. So, and that's what is actually being asked for. So what you should be thinking is, what information do I need to find this distance? And if you are thinking in terms of kinematics, displacement is related to the average speed or average velocity this way. It's average velocity times the duration of time. And that's a relationship that you're going to see quite a few times whenever you're doing kinematics. And in the horizontal direction, I do already have the average velocity. The V naught, that is my average velocity, because in projectile motion, the horizontal component of velocity doesn't change. So what I'm looking for here is the duration of time. And once you get that far, then hopefully you come to a conclusion after not too long of thinking that there's nothing in the horizontal direction that will give you the duration of time. So you have to look for this duration of time that the ball is in the air from the y component of motion. And once you get that far, then that's when you start writing down equations. So in order to find the duration of the motion of the ball, you look at find from y motion. So we need to write down kinematics equations as before. In a previous question, I wrote down the y position, and that seemed to work out well. So let me do that again. The y position is equal to initial y position plus initial y velocity times time, and plus 1/2 at squared, but I know acceleration is downward at minus g, so minus 1/2 gt squared. And this time it's going to be a bit complicated, because unlike before, this one go to 0, because now I have some initial y velocity that I need to worry about. So, so let me replace what I can replace. So I'm going to set my initial y height to be, reference y to be 0 at the ground, so that I can say my initial y height is the given value of h, height of the balloon. And this initial y velocity will be what I labeled as a VB. So this time I won't be able to just get rid of that. The y position at the moment, so I guess t final. At the moment the ball strikes the ground, the y position is 0. That's the t final I'm looking for here. So, all right. I see I can't really simplify anything here. So I do try to avoid this anytime I can avoid it, but for that is using quadratic formula, but for this question, we are just going to have to use quadratic formula. There's no way around it. So once you realize that, then you kind of give up and just write down the quadratic formula. T final is, let me write down the standard form first. It's minus b plus minus the square root of b squared minus 4ac square rooted divided by 2a. I need to identify those coefficients here. So it's doing that again. So here, this coefficient is a in the standard form. I hope you remember this is for the standard form written as a x squared plus b x plus c. So this is a. I'm making sure I include the minus sign. This is b, and this is my c. So let me put those in, I don't think anything will simplify, but let's see what we get. So minus VB plus minus square root of VB squared minus 4 times A. So I have two minuses, so that's going to be plus. 4 will cancel sum of 1/2, so it'll be 2G times C, or H, square rooted, divided by 2a. So 2 times minus 1/2 g. So 2 cancels out minus, or just 1/2. So I have minus g. And I can take care of this minus sign here. This minus cancels out this minus here, and it turns this plus minus. If we are being fastidious about it, it turns it into minus plus. All right, I guess I can't really simplify this much further. I can give an argument for keeping only the plus sign here, because looking at these two terms carefully, I can see that the term on the this term here is actually going to be greater than VB after you square root it, because it's a VB squared plus some positive number and then square rooted. So so it's the size of this number is greater than VB. So if I kept the minus sign, then I get a negative time. You can figure out what that means, but here it seems pretty clear my time final should be positive. So let me just keep the positive sign here. So doing that, I get VB plus square root of VB squared plus 2GH. The minus sign or the negative answer there isn't completely meaningless, but I think I did go over that in one of the recorded videos. It's basically dealing with the hypothetical trajectory that the ball would have come from if it was doing something that, yeah. So, all right, so I have the time, and I can calculate that as a number, but let me just finish this question algebraically, and then I'll plug in all the numbers at the end. The question is asking for the horizontal distance it's moved. So, so I found the time. So, okay, I just need to plug that in, multiply it with the given V naught to find the delta x. So, delta x is equal to V naught times all of that. So, well, I guess I'll write it out in two separate terms. V naught times VB divided by G plus V naught times square root of VB squared plus 2GH over G. And looking at it, okay, so it's not really going to simplify, so I don't think there's a real conceptual benefit in plugging in numbers here. So let me actually do this instead. I'll plug in numbers to get the numerical answer here, and then I'll just use the numerical value for the actual asked for answer here. Or I guess in the interest of time, I can leave that for you to do. So the reason I want you to at least write this out and see what the expression looks like is sometimes you can get surprising cancellations that simplifies your expression a lot. This isn't one of those, but you don't know until you write it out. And it's simplifying that kind of algebra skill is something you're going to need to develop from now until you graduate from four-year university. So good to get started now.